Hey everybody, welcome back. Today we're going to talk about testing for the symmetry of a given equation. And the benefits for a reason why you want to test for symmetry is that one, it helps us understand equations better, and the graph becomes a whole lot easier to plot. But also, if the equation is symmetric, it means portion of the graph are mirror images on the other side of a line. And there are three simple steps that we can use to test for the symmetry of a given equation. So first, what we want to do is replace the y value by negative y in the equation f of xy equals 0. And if the equation remains unchanged, then the graph of that equation is symmetric on the x-axis. Similarly, if you take the x value and replace it with negative x in the equation, and if the equation remains unchanged again, then the graph is also symmetric in the y-axis. And lastly, if you replace both x and y by negative x and negative y in the equation, if the equation again remains unchanged, then we know that the equation is symmetric around the origin. So we're going to walk through a couple of problems here and follow some examples and test this out and see what we get. All right, great. So now we're going to just try this simple equation. X squared plus y squared equals 25. Let's test to see if this equation is symmetric around the xy axis and around the origin. So step one is what we're going to do is we're going to replace we're going to replace y with negative y. So what we're going to get is x squared plus negative y squared equals 25. And what that's going to give us is, since you are taking a negative and squaring it, it's going to be a positive. So we're going to get y squared equals 25. So as we can see, this equation was unchanged by replacing y with negative y. So this is symmetric on the x-axis. So now let's try replacing x with negative x. So what we will get is negative x squared plus y squared equals 25. And similarly, squaring a negative just will give us x squared plus y squared equals 25. And this checks off, and we see that there is symmetry on the y-axis. Now lastly, what we're going to do is we're going to replace the x value and the y value with their negative counterparts. So we're going to get negative x squared plus negative y squared equals 25. And as we see, as with the previous two, it's going to be x squared plus y squared equals 25. And we see that this is symmetric at the origin. So this is a real simple problem that just tests that we can verify that we can show that we can find the symmetry on both the x, y, and around the origin. So let's do another problem. So let's try this. Y squared equals x plus 1. So we're going to first test the symmetry around the x-axis, and in order to do that, follow step one, we're going to place y with negative y. So I'm going to say negative y squared equals x plus 1, and negative y squared is just going to be y squared equals x plus 1, and yes, this checks off. So this equation, or this graph of this equation, will be symmetric at the x-axis. So now let's try replacing x with negative x for this equation. So we get y squared equals negative x plus 1, and here we get negative x plus 1. So we see that in this equation, it will not be symmetric around the y-axis because there's no symmetry. So there's no symmetry because the counterpart, x and negative x, bring out different equations. So now let's test it around the origin. And in order to test it around the origin, we need to place both x and y with negative x, negative y. So here we have negative y squared equals x plus 1. And we can see that we get y squared equals negative x plus 1, same as we did here. So this equation is obviously not symmetric at the origin. So this is just another equation. First one we saw it was symmetric on the x, y, and at the origin. Here is only symmetric only at the x-axis. Okay, great. Let's try one more. Let's try this. Let's do x times y equals 1. And so we're going to test the symmetry around the x-axis. So we're going to have x times negative y equals 1. And similarly, that equals x times y equals negative 1, because if you bring this is almost as if negative y is multiplied by negative 1. So if you brought that out and divide both sides by negative 1, it cancels out on the left-hand side, and you get negative 1 on the right-hand side. So those two equations are the same. But as we can see that this equation is actually different than the original equation. So we do see that there is no symmetry around the x-axis. So if we follow suit and do negative x times y equals 1 to see if there's symmetry around the y-axis, what we get here is xy again equals negative 1. And we see that there is no symmetry around the y-axis. So now let's see if there's any symmetry around the origin. And so to test the symmetry, again, we're just going to replace both x and y with negative x, negative y. So we get negative x, negative y equals 1. And this is as if you're multiplying by negative 1. So if we think about this, just so we can make sure we're on the same page, we get negative 1 x times x times negative 1 times y equals 1. Now negative 1 times negative 1 is just going to be 1, and you multiply it through. So that's going to equal xy equals 1. So here the equation is the same. So this equation is only symmetric around the origin, but it's not symmetric around the x and y axis. So this is definitely a different problem. So these are some pretty good tests, and you can try this with any equation to see if there's any symmetry. And this will definitely help you guys if you ever can't actually see the graph, but if you wanted to know if there was any symmetry, this is a good test to be able to prove that. And you can make some pretty good arguments if you have to deal with symmetry, that since it's symmetric, it's going to be a mirror image on the other side. But it's only symmetric if the equation, when you replace the x and y components with negative x or negative y or whatever variable that you have, and if you get the same equation back that the original equation, then you know that it's symmetric around either the x, the y, or the origin. Well, that's it for this video. I hope you found it useful. Let me know if it helped you out. And also let me know if you would like to see more than just 3 simple examples, problems worked into the videos. I'll try and do as many as I can, but I just want to keep a lot of these short, simple, and sweet to not try and bog you down or get too complex. So with that, I hope you guys have a great day. Take care.